Hello, my dear students, and welcome to my iPad and my kitchen. By the time you see this, it will be Wednesday, and we will be working on our next batch of material. If you go to Google Classroom and you go to, I already had it set up, sorry, you go to your class, you will see what I'm doing now, but what I'm doing now is simply going over the class notes for the material that I posted here. We talked about naming ions already, and we are going to go to naming ionic compounds. So what you want to do is open that up, and I've already opened it up and saved it to a file, and now rather than open it up in Google Docs or whatever it opens up in, I'm going to go back to our class stream for now and go to my program that is Keynote. It's kind of like PowerPoint, and let me exit show and go to the beginning and say that we have talked about naming the ions, both cations and anions, and now we want to put them together to make compounds. And compounds are like a recipe. Formulas are like a recipe for the compound. When we write the formula, we tell what's in it and how much of that what is in it. And so we're going to list the atoms, all the atoms involved, and do so by additionally saying how many of each type of atom is present. And our goal, of course, is to write the names of binary ionic compounds and write the formulas for them as well. And we want to write the formula given the name, and we want to be able to write or say the name given the formula. For example, gypsum. It's not just gypsum, it's calcium sulfate. And it's very common in plaster of Paris and sheetrock, and you can use it to make masks, or you can use it to make sheetrock, and I'm sure there are myriad other uses for calcium sulfate. But just quickly, when you name a binary compound, you first name the cation, and then you name the anion. So, for example, in our last example, calcium sulfate. Calcium was the cation, sulfate was the polyatomic anion. Another example, oops, they have this wrong here, is tin fluoride. That's the active ingredient in Crest, but notice they say tin 2 fluoride. That's the new modern IUPAC naming system that gives you a Roman numeral that tells you the charge on your metal. Tin is 2 plus, because there's a Roman numeral 2 there, although it's a transition metal and has multiple forms. And fluoride is always -1, so I need 2 of them to balance out the +2 charge, and I end up with a neutral ionic compound. Like I say, tin fluoride is the active ingredient in Crest. Others use sodium fluoride or different fluoride salts to get you your fluoride. Tin 4 sulfide, here the 4 indicates that this is SN4 plus. And sulfide is the anion of sulfur, and it has a -2 charge because sulfur is in group 6, and I would need 2 -2s to combine with my +4 to give me a neutral compound when they combine. So my formula is SnS2. This is how I would write it. This is how I would say it, tin 4 sulfide. Okay. Hematite, I actually have some hematite up on the board. It's an iron ore, very common, very inexpensive. The ones I have been polished in a rock polisher, but they're cool because they're magnetic, because they're ferrous metal. But here's iron 3 oxide, and this means I'm made with the iron 3 ion, and the oxide anion, which is a 2 minus. But my problem is I have a plus 3 and a 2 minus, and they don't go together 1 to 1 to give me a neutral compound. But what I can do is look for my common denominator, which would be 6, and if I take 2 irons at plus 3 and 3 oxides at minus 2, I'll have plus 6 and minus 6 and get them up with a neutral compound with the formula Fe2O3, pronounced iron 3 oxide. Now, when we write these formulas, we write the symbol for the cation and then the anion, like we just did. And we use subscripts to balance the charges, so we end up with an overall net charge of 0. Okay, so here's an example. Let me see if I can. It's copper 2 sulfide and potassium nitride. And copper is a transition metal with different forms, but the copper 2, the Roman numeral 2 in the name, tells us that it has a plus 2 charge. And the sulfide, we know sulfur is group 6, and it always has a 2 minus charge. And so these just come together with the formula CuS. The potassium nitride is a little bit different. Potassium is a group 1 metal. It always has a plus 1 charge. The 1 is understood, so you don't have to put it in there. You just have to put a plus there. But the nitride is the anion of nitrogen, and it has a 3 minus charge. And so to balance this, minus 3, I'm going to need a plus 3. So what we do is we put 3 potassiums together with 1 nitrogen to give us potassium nitride, K3N, written K3N for its formula, and pronounced potassium nitride, and written out when it's written out that way. But my charge is balanced. That's the important thing. So just to continue on and give you some examples, sodium iodide. Sodium is a group 1 metal. It's always plus 1. Iodide is a group 7 halogen. It's always minus 1. So I would just write this as NaI. Okay. Sodium iodide. Stannous chloride is something we should never say, because this is the old form. This should be written as tin Roman numeral 2 chloride. And of course that means that tin ion has a 2 plus charge. So my compound would be, chloride is always like iodide, a halogen, and always with a minus 1 charge. So my compound formula would be tin chloride, but I would need 2 of the minus 1s to balance the plus 2 of the tin. So this would be my tin chloride. For my potassium sulfide, sulfide is group 6, always has a minus 2 charge. Potassium is group 1, it always has a plus 1 charge. So when I write this, I'm going to need 2 potassiums to balance the minus 2 plus 1 potassium ions to balance the minus 2 of the sulfide ion. And calcium iodide, again, this iodide is a group 7 halogen. It always has a minus 1 charge. But calcium is a group 2 metal. It always has a plus 2 charge. And I would need 2 of those iodide ions to balance that. So this is how you write the formulas from the name. And, given these names, you should be able to work back from those formulas. The only trick is when you're writing these formulas and you get a metal that is a transition metal in the D block with the D electrons, then you have to include the Roman numeral for the charge on it. So tin chloride, if I didn't know what the charge on, or what the different forms of tin were, I could tell here that because it has 2 minus 1s from chlorine, it must be a plus 2. The other form, of course, is the plus 4 stannic form of tin. Let's go on. How do you write the formulas and names of compounds containing polyatomic ions? You do it the same way you did with binary compounds, except now instead of two individual ions, you may have one or two polyatomic ions coming together, a positive and a negative one. So you write the formula for the cation followed by the formula for the polyatomic ion, and you balance the charges, just as we did before. For example, calcium nitrate. Calcium is that group 2 metal with a 2+ charge, and nitrate is a polyatomic ion, one of the more common ones, with a single minus charge. So it means I'm going to need 2. And when I write that calcium nitrate, my problem is I'm going to need 2 of them. But if I write it like that, it looks like I've got 32 of them. So because these stay together as a group, we frequently include them in parentheses. So I will write parentheses indicating that I've got 1 calcium atom and 2 nitrate anions. Okay, and so that means I would actually have a total of 2 nitrogen atoms in the compound and a total of 6 oxygen atoms in the compound. It's getting much more complicated. So this would have 6, 7, 8, 9 different atoms in it. Moving on, calcium carbonate is found in the shells of mollusks and is known also as chalk, and even the oyster. I mean, not the oyster, the pearl, but and the pearl or mother of pearl lining of the mollusk, but found in chalk deposits, limestone, marble, and alabaster. Anyway, the calcium is a 2+, and the carbonate is a 2-. So calcium carbonate is simply written like that. You don't have to put the parentheses around it because the 1 is understood, okay? But it is written calcium carbonate like that without the parentheses. I wouldn't penalize you, I guess, if you did. It would just look odd. So lead sulfate. Sulfate is a 2- charge, and I will tell you now, you don't have to memorize all these polyatomic ions. I'm going to give you and provide you a chart when we have a test or any other time when an assignment requires them. You can look them up in that chart in yesterday's lecture notes, or you can always Google them or find out. Lead 2, this is great. I love this new modern terminology because it tells me that my lead has a 2+ charge. That Roman numeral is equivalent to the charge. Well, there's a 2+ and a 2-, so lead sulfate is PbSO4. Actually, the sulfate is present as there's sulfuric acid. We'll talk about acids in a couple more days. But this is a lead acid battery, and lead sulfate is produced in there. So let us move on. It says, write the formulas for these ionic compounds. Magnesium is Mg, 2+, it's a group 2 metal. And hydroxide, if you look in the chart of the ions, is an anion with the formula OH-. This is a 2+, this is a 1-, so I'm going to need 2 hydroxides. And potassium sulfate, potassium is a group 1 metal with a single charge. And sulfate, as we just said, has a 2- charge, so I would need 2 potassiums to balance the charge of my -2 on my sulfate anion. So again, those polyatomic ions, I just know them, but you'll get to know some of them as we work with them, and others you can always look up in the charts, okay? So there's your answers to those. So now it says write formulas for the following compounds. Now, the first one is very interesting because it's made up of a polyatomic cation, the ammonium ion, which has a +1 charge, and the sulfate ion, which has a 2- charge. So I'm going to need 2 of these +1s. So my parentheses go around the front polyatomic ion, and I put the 2 subscript indicating I've got 2 of these ammonium ions. And calcium phosphate is PO4 3 minus, and calcium is a group 2 metal, 2 plus, and here's that 2 and 3 again. So I'm going to need 2 minus 3s and 3 plus 2s to give me a balanced formula for this compound. And I will also add that this is about as hard as it gets, balancing a 2 and a 3, with a few notable exceptions, but that's about as complex as you'll get. Now, when you name compounds with polyatomic ions, you state the first cation first and then the anion last, just like we did with the binary compounds. So here's sodium hypochlorite. This is the active ingredient in bleach, and it's used, of course, for sterilizing, including swimming pools. And this ion here is called hypochlorite, and it's a -1, and the sodium is a +1, so there's your formula. That's simple. So let's answer a few questions, and then let's go to our homework. The correct name for chromium with chlorine or chloride ions, more correctly, 3 of them is chromium 3, because chromium is a transition metal, chloride. So you would not say trichloride. This yellow box is in the wrong place. I think that's because I'm using a different program. It would be chromium 3 chloride. Because you don't have to put the tri in there like you do when we'll get to some compounds later, because it's the only way it'll work. If you have chromium 3, you're going to have 3 chlorides, and this is the only possible arrangement. So we don't add the tri. I don't know why that was a yellow box. For strontium nitride, strontium is a group 2 metal, so it's +2, and nitride is -3. So you're going to need strontium, 3 of those, and nitride, you're going to need 2 of those. So my answer here would be A. I hope it doesn't show that, but that is the correct answer, the one I said, not the one that's appearing. And it says, which of the following compounds is named correctly? This is a very difficult question because it asks you 4 questions in one. Sodium chlorite, this is the hypochlorite ion, and so this would be ClO2 for chlorite. And you would just have to know that by looking up these ions in the table, or have worked with it a long time like me. Potassium nitrate, nitrate is actually NO3. This is potassium nitrite. So this is not correct. Sodium acetate, that is the correct formula for sodium acetate, so I'm sure that's our answer. But let's eliminate the last one, which is lithium, which is +1 sulfate, but sulfate is actually SO4. So they have it is 2-, so they have it balanced properly, but this is not this would be lithium sulfite if you look up your ions. So again, the answer is C. And that does it for our presentation. But let's talk about the assignment that I just posted and see if we can get this to work and be fillable so that I can show you something. I cannot use my Apple Pencil in this Google format, so I discovered, but I can quickly use my keyboard at least now. So binary compounds are named by writing the name of the cation first. And I'm not going to always be giving you these answers as we go through here, but during these snow days, I want to go over these and I want to give you the answers while I also give you some commentary. So your price for getting the answers to your homework is you have to listen to me. Followed by the name of the anion, although I will try to go quickly. For example, NaI. Okay, oops. Names of binary compounds end in, see if I can do this, end in ide. And for example, NaI is sodium iodide. And when a cation has more than one ionic charge, a Roman numeral or a Roman number, that's just the way I learned it, is used. And compounds with polyatomic ions whose names end in ite or ate contain a polyatomic ion that includes oxygen. As we pointed out last time. And in writing the formula of an ionic compound, the net ionic charge must be balanced or zero. Okay? Now, going through the true-false, the systematic name for baking soda is sodium hydrogen carbonate. That's the old trivial name or classic name, so that would be NT, never true. And then next, I don't know why it's jumping around on me there is number 10. For writing a formula, the ionic charge must be zero. We just said that was always true. So let's move on to number 11. Anions containing oxygen end in ite or ate. So that's sometimes true. What about oxide? That doesn't end that way. And the cation name is placed first when naming ionic compounds. That is always true. I don't know why it's jumping around as I do this. So let's go on to our matching. And binary compounds are B, ionic compounds composed of two elements. Monoatomic ions are A, ions that consist of a single atom. Polyatomic ions are D, ions that consist of more than one atom, hence the polyatomic. If you break down the word and the word roots. And transition metals, the only thing left is C, but it is true that they may have more than one common charge. Now, we need to name these following compounds. Iron's a transition metal, so it has more than one charge, so this is iron. And I need to go to my parentheses, iron, 1, 2, 3, close parentheses, bromide, and this is binary ionic. Binary ionic. And the next one is potassium hydroxide. And this is ionic with a polyatomic ion. Okay, and the next one, this is a dichromate anion. You would have had to have looked it up in the formula. It's one of the more, I guess, complicated ones, one of the last ones chemists learned. But this is sodium dichromate. I use it mixed with sulfuric acid to make a cleaning bath. But we're not supposed to do that anymore because we don't want to release that into the environment, because chromium's a heavy metal and not necessarily good in the environment. And again, this is Ionic. I'm wondering if I can highlight that. Nope. And copy it and paste it. But I will just type it out again. This is Ionic with a polyatomic anion. Now it's writing the formulas for the following compounds, and I'm sorry, but I cannot write my numbers as subscripts, so I'm not going to do so. But this is NaClO4, Cl, little l, back to a capital O for oxygen, 4. Those numbers, again, should be subscripts if you have that capability. Lead phosphate, phosphates minus 4, phosphates minus 3, lead 2 phosphate is what they're saying, is plus 2. So this would be Pb, and I'd need 3 of the minus 2s, and then 2 of the minus 3s. So P, phosphorus, O, oxygen, 4. And I forgot, I'm going to need to, oops, I can't move my cursor. So let me go back and do my parentheses and do my PO4 close parentheses, and I would need 2 of those because they are minus 3 each. Again, those numbers would be subscripts. And finally, I have magnesium hydrogen carbonate, and magnesium is a plus 2 and hydrogen carbonate is a minus 1. So I'm going to need my 2 of those. So let me go to my parentheses again. And this would be HCO3, close parentheses, 2 of those. And there is your assignment. And we went over it because these are important terms, that good questions that require and deserve some annotation and some discussion. Anyway, that completes this lesson. We will see you tomorrow with another one, and then we will spend Friday doing makeup and finishing our labs. I will post the lab discussions really probably by tomorrow, especially for our virtual students who never got to see the labs and who might be a little behind and didn't have the discussion in the classroom. So goodbye for now. Stay safe and stay warm.